Kia ora te whānau. My name is Jason Ingham, and it's a great pleasure to be able to speak to you this afternoon. I've actually noticed a few people I've already talked to as they've walked around the building today. In 1985, I came to the University of Auckland in my first year of undergraduate engineering, which is a long time ago now, obviously. And in 1995, I started here as a staff member. So I've been here on the program for 24 years in civil and environmental engineering. And I started at the most junior of junior all grade levels, went through the lecturer scale, the senior lecturer scale, associate professorship, and I'm now a professor and the head of department of civil and environmental engineering. And it's my great pleasure to share with you this afternoon my thoughts on what civil and environmental engineering is all about, why it may appeal to you, or perhaps you'll be better informed on why it wouldn't. And also to sort of share with you where your careers are likely to go as you sort of project forward for the next 20, 30 years. Oops, going the wrong way. So if you've already had a chance to walk around the demonstrations, you may already have a good sense for the different forms of engineering that we have across the different departments. And I highly respect all forms of engineering, and I often think it's just human nature that everyone else's projects seem to be a little bit more interesting than your own. So when I have a look at what's going on, it's like, okay. Civil environmental engineering is the oldest of the traditions of engineering. And the word civil is the same word that we use for civilization or civilian. And so I like to sort of re-flavor the words a little about this being the engineering for people and the environment. And it did occur to me when you look at this picture that there's a few things in this picture that are not civil and environmental engineering. There are actually some yachts and some motorboats, and I guess if you look closely you might see some cars. But almost everything else in this picture is civil and environmental engineering, right? So everything that's roughly green and blue is our beautiful, unique New Zealand environment, and it's the role of environmental engineers both to protect our environment, kaitiakitanga, guardianship of our environment, and also to correct any past wrongdoings. That's the environmental part, but then everything else that you can see in front of you is what we call our built environment. And so when you think of that, it's the scale and the complexity of civil engineering that sets it apart from the robots or the rockets or the 3D printed guitars or whatever else you might have seen out there on display. So every single built structure in this picture will have been designed, and probably its execution will have been monitored and checked by a civil engineer, right? So you can see already, hopefully, the huge diversity of work that entails, the huge opportunity for employment, the huge opportunity to influence our society. So, the reason, well, in some forms of engineering, the technology is advancing very quickly. The software is changing very fast. The tools, even the things you're making are changing. I often think of a phone. If your iPhone packs out after 12 months, then you sort of just assume, well, it was a phone. Okay, I'll get a new one. Civil environmental engineers think in very long time horizons. If you're building a structure, at the very least, you're expected to be around for 50 years. But if you go and have a look at our oldest buildings in Auckland, they span back to 100 or more years, right? Our whole career is focused around people and the demands of people and the impact of people. And the reason you can see that we will have such a stable and continuous work environment is by charting the forecasts of what the global human population is going to look like over your career times. Right? So if you guys are thinking about coming to engineering school maybe next year, maybe the year after, we're talking like 20, 21, 22, you'll be out in the industry maybe by 25, at the age of roughly 25, I hadn't realized this, works quite well, right? So people retire at like 60, 70, 2070, you can see here what the forecasts are for global population, right? Billions of people will be on the planet that aren't on the planet currently. And not only that, in modern developed societies, they're striving continuously for further improvement, but in particular, in developing societies, they all have aspirations to live the same quality of life we already have. And all of that is going to demand massive investments in civil environmental engineering infrastructure. So the workload of finding all the houses and homes and buildings and water supply systems and roading networks for several billions of people that aren't already on the planet, and also just the mega cities and the urbanization of global population means there's just massive work on the forward horizon. Now, one of the things, I'm a structural engineer, and so water engineering isn't really what my primary focus area is. But hopefully you all appreciate how water impacts on all of us. Not only without water will we not survive, we need to drink it, but we need to wash in it, our hygiene, flushing our toilets, everything. It's all around us. And in Auckland, of course, it's either raining or we've got the oceans, everything around us. Water has been forecast to become a scarcity in our lifetime. And in some parts of the world it already is. So how we deal with the capture of rain, how we harness it, how we bring it to our houses, how we treat it, and how we put it back into the environment safely is going to be massive. There is a forecast that in our lifetimes there'll be extreme issues around water that we need to tackle. This one, from what I can tell on the radio, some people are still sort of wondering what climate change means, sea level rise means. I'm quite certain as an individual, not that I'm trying to sort of tell you how you should think, but it is massive. And I can tell you as head of department here at Civil Environmental Engineering that we have a strategy that not only are there engineering schools all over the world and civil engineering programs all over the world, but we strive to distinguish ourselves in the world scene by having our focus on Treaty of Waitangi issues and Pacifica. And so issues around climate and sea level rise to our New Zealand environment and to our Pacific Island neighbours is huge. And what you're looking at here is the fact that so much of the global population chooses to live right on the water foreshore, right in the areas where over your career times we are expecting to see sea level rise and huge amounts of engineering needs to protect those structures and those people. You can see the data there, 570 coastal cities and 800 million people will be needing to be attending to sea level rise. Can you imagine how much work that's going to be? That's civil engineering, right? Transport. I find transport just really quite boggling, really, when you think about it. We all travel, and we all typically travel in cars. Vehicles are changing. Right? They're both a machine, mechanical engineering. They're both an electronic device these days, electrical engineering. But transport is a civil engineering issue. So how you got here, you'd have driven on roads, pavements. We had that pavement design. How do you deal with the potholes? When you stopped at the lights, how long do the lights stay that colour? How many lanes were there? Where did the road even go? All of that. The transportation issues of the world are all civil environmental engineering, and it's revolutionising how we travel. So we're making staff hiring decisions right now. Electric cars you're probably very familiar with, right? So they've got batteries, you don't put petrol in them. Autonomous cars are the ones that detect each other, and so now they can all drive down the road together, and driverless cars basically, right? And so all of a sudden, in our lifetimes, we're expecting that we'll have cars that sense each other and potentially don't even have a driver in them. Now that actually brings with it huge social and ethical issues around what happens if a driverless car sort of crashes into somebody. But our whole model around transport is changing. That's globally. It would be wise for you to be worried about both, your employment opportunities when you get out into the workforce. Have you picked a career choice that's sensible? And also, does it pay well? Civil and environmental engineering projects can be extremely expensive. So right now, WaterCare is just committed to building a tunnel underground. $1.2 billion. Civil engineering project. We've just had our brand new engineering school being built across the way. I can't actually remember how much it is. We're about to build a new gym across this side of the road. I think they're both in the vicinity of something like $100 million, but I can't remember the exact numbers, right? Civil engineers are responsible for huge projects that cost millions and millions. And people want to pay you as smart people to invest wisely in how those dollars are spent for the betterment of society. Okay, so if we think about sort of the global issues, right, you might say, okay, a couple of billion people added to the planet, but maybe that's happening in Asia, maybe that's happening in North Africa, where it's happening. You know, what's its relevance to our program? It'd be wise for you to be thinking, yeah, but I mean, are these guys at the University of Auckland going to give me a qualification that's worth something, right? So here we are, we're actually in this lecture theatre with the neon stuff on it right now. How does this relate to here and now? So, population. Well, what's happening globally is expressing itself right here in our classroom in our city, right? So when I was a student in '85, fact are, most of the people in the room when they were students, white males, right? Now, when I teach out to 1,000 first-year students, it's just a multitude of people from all over the planet. So you're all aware, Auckland apparently is one of the most multicultural, most culturally diverse cities in the world. And it's forecast to double in size in our career times. Probably yours, not mine. I'm not sure I'll be working in 25 years from now. But you guys should be, right? We are dependent on people like you guys in this classroom to double the size of Auckland in your lifetime. That's a heck of a lot of design, right? Where are we going to put all the people? How are they going to get to work? How are they going to have good sanitation? How are we going to keep the environment clean? All of that is what you have if you choose to get into this career point. You're probably aware around Kiwi Build. It's attracted a lot of attention in the media, some good, some bad. But there's no doubt with population growth, we need to figure out how to house people, and it's got to be good, quality, healthy, safety housing, right? We have an issue that many of our houses are really quite dubious in the quality of their homes. We need to be making affordable construction, but also high quality. All of that is civil engineering. Water. You must have noticed, right? They've been saying on the radio the last few days, 27 days in a row of rain, all sorts of strange weather patterns that we're not used to seeing. What are we doing with this? The city's flooding, we've got the waves coming up over the footpaths. How we attend to designing our city to be a safe, affordable, sensible city, tackling all these water issues. Oddly enough, if you have a look at what this picture's showing you, it's actually saying that there's been a water storage. Why is that? Well, over the summer times, it's raining so little. We've been having such hot, dry summers that all our reserves are down, catchments are down. We're potentially in a situation where we might be running out of water. Here's this project I was telling you about, right? I think it's interesting to bring it up, basically, because people don't like talking about it. When you flush the toilet, where do you think it goes? Who do you think's looking after it, right? You've got millions of people every day going to the toilet. It's a pretty important issue because it's really going to make the city a pretty nasty place if no one's taking care of all that stuff. WaterCare are investing in huge amounts of money to ensure we've got world-class sanitation systems in place. And, you know, when Auckland's talked about internationally, it's most of the one livable cities, beautiful environment, and yet it's got these sorts of things, right? High risk of contaminated water, because if you're not careful, what you flushed down the toilet last night's now sitting right there on the beach next to you when you lay your beach towel down. That's not going to be a very nice thing to deal with, is it? So, may as well just start talking about it. It's pretty important stuff. I'm a structural engineer. Bridges and buildings is what I do mostly. We need a second harbour crossing. People have been talking about it for like 50 years. Currently we're building a city rail link underground, right? Millions and millions and millions of dollars worth. Where are we going to put the people? how are we going to effectively manage to travel to work and home every single day, right? Then there's issues, all sorts of issues you can think about, right? Lime scooters arrived just like a year ago or half a year ago. Look at the investment, $28 billion over the next 10 years. Big numbers, lots of investment, basic quality of life issues, so we can all enjoy living here. This is actually what I do. So I was in Christchurch on the day of the Canterbury earthquakes. This is my picture. I walked out of the central city. I was just around the corner from the site. I didn't know my career was going to go in this direction when I started it, but I became fascinated in heritage and old buildings and how to keep old buildings up in earthquakes. So that's my specialist area. But I bring this up because up until now I've really been talking about building new stuff. We also have another massive challenge. Most of our existing structures and our infrastructure and our roading was all designed to last about 50 years ago. And guess when it was designed? Well, most of it was designed after World War II, which happens to be about 50 years ago. Which means most of our buildings, most of our pipe networks, most of our roads, they're running out of life, basically. So it's the continuation and the preservation of our existing infrastructure that's also going to generate a huge amount of challenges, huge amount of work. Okay, now I hope, maybe I oversold it a little bit, I hope certainly you got a sense of the scale and the amount of work to be done, and it's connected to it. Here's how we operate as a degree program. And so you're probably well aware that in your first year in engineering, you actually just do a common first year. You don't have to make a decision. Even if you really quite passionately know what you want to do, everyone has to take the same thing. At the beginning of the second year, you start in your degree. And in civil and environmental engineering, you pretty much have no choice in year 2, and you do a little bit of everything. But over time, you can start picking the specializations that you prefer. And I've spoken to some of you already. I've been out there all day just telling people that you don't have to sort of panic too much about this. I don't think you need to somehow today be thinking, oh yes, 5, 6 years from now, that's where I want to be. It takes care of itself. Most of the employers in New Zealand know our degree program very well. A large number of all the professional engineers in New Zealand have come out of our program. So there's a lot of communication going on. But just to understand it, structural engineers, top left there, so they're interested obviously in bridges and buildings, both the design of new ones and also developing, extending and improving old ones. Geotechnical engineering is the complexity of understanding how you dig into the ground and you engineer into the ground. And the complexity is around the fact that it's such a variable material that you have underneath you, and it changes so much that you might be on one side of a building site and on the other side of a building site and they're completely different. So it's all the sands and the silts and the clays and everything else. The topic of liquefaction became extremely publicly aware after the earthquakes when so much liquefaction occurred in Canterbury. So geotechnical issues, tunnelling. I was talking to the water care people last Wednesday night. They invited us to a function. And they were just talking about how many large tunnelling projects are scheduled to come up in New Zealand in the future. So more and more we're building under the city to hide away the underground infrastructure. But it's also retaining walls, foundations, and other good things like that. Transport's rather obvious, right? But it's the whole spectrum, almost anything you can think of related to transport. So where's the road going to go? How are you going to design it? Communication with iwi and other such things around how we sort of plan that out, and then how many lanes, traffic lights, the whole thing. Hydraulics, as it's called here, tends to be basically the study of water in a civil engineering context, all the way from when it rains and it goes into the catchments, down into the streams, how we do with flooding, how do we catch it in dams, how do we get into the pipe network systems, how do we get to the homes, how do you drink it, how do you wash it out? So you've got your dirty water, your clean water, your storm water from when it rains and floods. So it's river hydraulics. New Zealand is one of the most steepest countries in the world. All the way from our mountains to our coastlines is a very short horizontal distance. So we have a large number of rivers and a lot of flooding issues there. And then a program under my leadership we're bringing on board is a lot more focus on coastal engineering. So most of the New Zealand population is on the coastline, so in the Pacific Islands, and there's a huge amount of coastal engineering that we need to be thinking about. Environmental engineering, we're recruiting into very large program recruitment there, so we've got more staff on board, and we're going to get a lot more active around environmental engineering, and so that really speaks for itself. It's all the way from the micro to the macro. So if you're trying to do things like make sure you've got good quality water, then you need to actually understand about things like heavy metals and sort of tiny little microbes and all sorts of things in the water, all the way to the fact that if you're looking at the Waitemata Harbour, you know, how do you actually deal with the whole environmental impact on the eco-scale system? And the last one is all of this stuff has to be built, right? Cost engineering, supply chain resource engineering, the materials, the construction, and also the numerical modelling that goes with all of that work. Am I talking too long? How long am I supposed to be talking for? Ooh, better speed up. Okay, so here's structural engineering. Structural engineering, we have the traditional materials, timber, steel and concrete, most of the traditional ones, bricks as well, masonry that I do, so they're all listed out there. A large amount of work around structural modelling. So ordinarily, complex structures, you've got some sort of numerical modelling. We've got some displays outside about structural dynamics. In New Zealand, earthquake engineering of structures is really our governing issue. And so New Zealand really has been one of the world leading countries around earthquake engineering for structures pretty much forever. So as you can see there, it's the buildings and the bridges, and as I've mentioned to you already, maintaining them, the existing structures. It's what we call retrofit, so you might have to strengthen them as we lift our earthquake standards. I thought this was cute when I saw this picture, so everyone probably knows this is the Leaning Tower of Pisa. That's not in Auckland, if you hadn't realised, that's in Italy. It's rather famous, it's a very classic example of what happens when you get your foundation design wrong, right? So foundations of structures, but also slope stability, landslides. KOUTOU earthquakes was a very good example of that, and I mentioned already tunnelling. Transport, the whole thing. Now evacuation is also very interesting. We're doing some modelling on what happens, for instance, if there's a volcanic eruption in Auckland, and you'd think everyone would behave sensibly, and they get in their car and they try to leave town, but you find out that actually, no, that's not quite true. Everyone thinks, oh my gosh, the dog's at home, and they drive in the opposite direction against the flow of traffic, and it's all sorts of carnage. And so evacuation modelling and other such things is really quite interesting. I think there's becoming a lot more attention on how people want to travel, right? The social context of taking public transport, trying to create less of a carbon footprint, all of that stuff around cycling and walking. You know, if you have a look around Auckland, you'll see the more and more cycleways being put in all the time as people try to create these low impact opportunities for transport. We've discussed this one already. Tsunamis is another very good one, right? So we're in a high seismic zone, and with that we can expect tsunamis. We haven't had any of any major size in our lifetime, but there certainly have been some very large tsunamis in the past. If you can imagine a wall of water up to 10 meters high, what that might actually mean if that comes crashing down on a city, pretty severe stuff. Environment, we've talked about again already, the 3 different sorts of water, and it might seem simple, but it's huge, and it's expensive, and it's important. When the water quality is impacted, people die, right? So having healthy water coming to your house is probably more important than having a good doctor. Right? They've had cases where local water supply has been contaminated and whole groups of people are dying of poisoning. Construction we've discussed already. Cash flow issues, right? We got Brexit and we got Trump and we got all sorts of global things going on around the economics of the country. One of the primary indicators of the health of a country is how much it's investing in its construction, civil engineering. Okay. Here's our sketch-up of our brand new building. Civil engineering is the largest department in the faculty, and it's also the highest ranked. So I'm really quite proud, seeing as I'm the head of this program, that we certainly aren't one of the 30 biggest cities in the world, if you think of all the cities in all the world, but we work very hard to try to be one of the top programs on the planet. So we've got a very strong reputation. We're particularly strong in earthquake engineering, And we managed to convince the Vice-Chancellor we needed a brand new structural testing laboratory. So here's a bit of a distorted view of it. It's not the biggest structural testing laboratory in the world, and I think it's a bit silly if we thought we would want to have the biggest in the world because we're not a big country. But nevertheless, it is a world-class facility doing world-class work, and it's going flat out. And we've got people from all over the world who come to study with us in this facility. That's where we test engineering solutions before they go into buildings, making sure that they're safe. Geomechanics. What we're doing here is we're typically getting soil samples and testing their various characteristics so we can make sure they're safe to build on. The water labs is what we call flumes, and so they can imitate our river flow. We've also do models there for open channel flow for things like rivers and flooding and how various cities might want to have flood bank protections and other systems so they don't flood. Transport lab is mostly associated with investigating aspects, bitumen, asphalts, various other things. What we also have at the moment is working on a project around what's called inductive power transfer. So this is where you might actually have sort of electrical supply lines in the road, and the power from the cable in the road can power the vehicle that's driving over the top of it, and how we deal with that from a pavements issue. Environmental lab often reminds me, rather rudely I should say, as if there's a whole bunch of photocopiers sitting on the desktops. They're extremely expensive photocopiers. Each and every one of them has some fancy function that sort of tells you the heavy metal concentrations or the microbe concentrations. And they had a pop, they're sort of like $100,000 each, and if one of them goes wrong, it's always very expensive. But we have a world-class laboratory facility. We're routinely hosting professors from all over the world, some of the most famous universities coming here to use our gear. And what we're also doing is we're trying to reconfigure what we teach and how we teach and how we go about it. So MDLS stands for Multidisciplinary Learning Spaces. And it's a global phenomena that students are learning online more and more. They're less enthused about coming to class. Heck, if I can watch it on the internet, or you can download the recording, why should I bother coming along? We are working hard to sort of get rid of that whole format, like is actually happening here right now. I'm doing all the talking, you're doing all the listening. If you get this recording, you might just stay at home and watch it on the recording. We're turning it so that there's going to be a lot more interactive learning, a lot more engagement with staff, a lot more working together in teams. So it's a fairly major issue, but in our brand new building, we've built 20 new MDLS learning spaces, and our challenge for ourselves now is to take what we've been teaching in the past, me standing up the front, and figure out how we do it much more interactively, so that you'd be a bit of a fool to stay at home and watch it because all the good stuff's actually happening there in the classroom. Our student association, it's self-run, self-government, self-formed. We give it a little bit of money each year, but otherwise it looks after itself. They have a whole lot of social functions and activities. And this is the closing slide here. I'm hoping that I've helped to give you some sense of what the career is like, how it's a career whose purpose is to help society, that a career won't require retraining. So you've got a career for life. You should be attracting high salaries throughout, so you might not be the richest person on the planet, but nevertheless you should be in a very comfortable career point. And it's a degree program that you can take with you all over the world. So civil engineering at Auckland is highly respected internationally. Our graduates end up getting jobs all over the planet. So ka kite anō, thank you very much. I'm happy to stay here and answer any questions. Hope you enjoyed your presentation. Thank you.